Well, let's take a look. Let me get the recording going here. There we go. Let's take a look at the introduction to the practice of statistics. Some definitions. Mainly this section is just definitions. Let me get some of that out of the way. There it goes. Okay. Statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. Statistics is more than just analyzing what's happened, but it's using that to tell something about the future. Maybe to tell something about the population, which we'll talk more about. Now, population is the entire group of individuals to be studied, while the individual is a person or object that is a member of the population being studied. And then sample is a subset of the population that is being studied. For example, if I decided to open up a casino down in Ark City, maybe my population might be everybody that's 21 years or older in the entire town, which might be quite a few. There might be like, I'm not sure the population, but let's say 7,000 people. That'd be a lot for me to go around and talk to all of them. So instead of doing that, I talk to a sample of them. I'll pick like 20 of them and ask them what they think about me opening up a casino. And based upon the results of that sample, I'll use that to extend it out and to see what the population actually thinks about it. Now, we have a statistic, which is a numerical summary of a sample, and a parameter, which is a numerical summary of a population. So, statistic is sample, parameter is population. Let's take a look at our first example. It says determine whether the underlying value is a parameter or a statistic. Remember, statistic is sample, parameter is population. So P for population. Okay. The average grade for a class of 25 students in elementary statistics was 83.2%. Now, see how this does not refer to a sample at all? It does not say, like, out of a sample of this, we can say that all the students in the entire college are this. This is just using my class as a population. So this is a parameter. Now here, this says in a survey of 12,000 high school students, 74% of respondents indicated they achieved at least once on an exam in the past year. So what they're using this for is using this as a study, a sample, to extend that about all high school students. And this was actually an ABC News story. And so this would be a statistic, because this is a sample. It says in a survey, it's found that 10% of married people have had extramarital affairs in the last year. Again, the implication is that of all married people, 10% of them have had affairs. So this is a sample. Again, if it refers to a survey or sample, then it's a statistic. If it's a population, it's a parameter. In a particular elementary stats class, only 50% of guys wash their hands after using the bathroom. This isn't referring to that survey or sample, is it? It's just saying that out of this class, 50% don't wash their hands. Or wash their hands. So this is a population, so this is a parameter. Now the process of statistics, excuse me, identify a research objective, decide what you're going to study, collect the data needed. So go out and if you're trying to figure out what the average age of college students are, that's your objective. You go out and collect data. You ask them their ages. You describe the data, so you summarize it, you find the average, find the mean, and then our last step is you take that, then you tell something either about the future or about the entire population. So you use that sample of 20 students, for example, to tell what all the students are like. Or you could use it to predict the future. And we'll talk more about that. Now, our fifth example says determine the research objective, the population being studied in the sample. This says investigation of repetitive transcranial magnetic stimulation of depressed adolescents. Now, I tried to find examples on the internet, so I have no clue what a lot of these words mean. Magnetic stimulation, I'm assuming they're stimulating with magnets, but let's see. This research proposal aims to better understand the neurobiology of depression in adolescents and how repetitive transcranial magnetic stimulation may therapeutically impact brain function and mood. This research will be the first study evaluating metabolic changes in the brain as a result of rTMS treatments in depressed adolescents using magnetic resonance MRS. Okay, research objective. They're trying to see if the magnetic stimulation may impact brain function and mood therapeutically. So that's what they're trying to study. Population. Well, that's going to be all depressed adolescents. The assumption would be the United States, but we'll just say all. And a sample. They don't really talk about the sample, but presumably they're going to find a sample of depressed adolescents, and they're going to apply this technique to them. So those will be our three. 6 example. Determine the research objective, the population being studied, sample, and descriptive statistics. Beat Bullying, I'm not sure if that's a website or what, found that up to 44% of suicides among 10 to 14-year-olds may be bullying related. The charity said 26 out of 59 cases reported in the national media were linked to intimidating behavior. So what they're studying is their implication is that bullying causes suicides, or at least a certain percentage. And the population being studied, 10 to 14-year-olds. So that'd be all of them. And what they're actually studying is they're not like pulling a sample of 20, 25, sticking them in a room, see how many kill themselves. But they're looking at past statistics. So what's happened already. So that's the sample would be, doesn't really indicate here. Oh, there it is. Charity said 26 out of 59 cases. So they're studied those 59 cases and found 26 were linked to the behavior. Now that 26 out of 59 is actually our descriptive statistics. That's what we use to get the proportion. So you can take 26 divided by 59, and I haven't actually plugged that in the calculator, but the assumption is that gives you your 44%. Now, we alluded to the descriptive statistics. That consists of organizing and summarizing data, and then through that, the data can be summarized in tables, graphs, summaries, and so forth. Now, that's describing what's happening. Then the next one is using that information then and extending it to a population, or maybe using it to predict the future. My example of the casino, we're using the sample of students, or the sample, to tell what the entire town of our city would like in terms of a casino. Sometimes you use a sample to tell maybe what's going to happen in the following year, or you just not even a sample, but you look at all your data. Oftentimes in business, they ask you to predict what the sales is going to be the coming year. And that's where I worked at IFR. That's what they do. They would predict bookings. Now, sometimes it had already been told ahead of time that these contracts were coming down, but then sometimes they had to estimate what kind of contracts. And the reason why is that's important to be able to predict the future is if you hire somebody new at McDonald's, as I understand it, they got a little device that has pictures of food, and you push the picture of the food, and the training on it is probably not real intensive. You probably get the hang of it maybe after a day or something like that. They probably train you for a week or something, but I mean it's not that intensive training-wise. At IFR, you have people that do very detailed work, electronics, and to train them may take 4 months. So if you got a contract that comes up, and you need an additional 15 people to work that contract, and they want it in 6 months' time. Well, if it takes you 3 months to train them, where you're going to have them being trained, and then you also have current employees training them, you got a huge amount of your workforce tied up. So that's why it's important for you to use statistics to help try to predict what's going to happen. Now variables, this is the characteristics of the individuals within the population, weight, age, etc. We have two different types of variables. Qualitative, this is categories. Quantitative is a numerical measure of some sort. Now a numerical measure that makes sense. The seventh example says classify the variable as qualitative or quantitative, and the example is hair color. Well, this is qualitative. Quantitative again is a number. Number of pets. Well, this is quantitative. You have 5 pets, 2 pets. So you have it's a number, and it's a number that actually is a number. Social Security number. This is actually a qualitative. Even though quantitative, it's a number, but the number really doesn't mean anything. This number doesn't mean, if I got the Social Security number 000000001, that doesn't mean I'm the first person born in the United States. It's a number that's assigned to you. So sometimes numbers are assigned to you, like numbers on a jersey. If you got the number 1 on your football jersey, it doesn't mean you're the number 1 player. It's a number they gave you. So it's actually qualitative instead of quantitative. Quantitative means it's a numerical measure that you can do operations with. Now, assessed value of a car. This would be a quantitative. It's worth $3,000. Definitely saying something's worth $3,000, something's worth $6,000 is definitely a different meaning. Means it's worth twice as much. Now we got two other ways to classify variables: discrete. Basically, the key part here is no decimals, and continuous, which means it has decimals. Now these are kind of a little bit confusing because some people may interpret something as discrete and it's really continuous, or vice versa. Okay, so number 11 says determine whether the quantitative variable is discrete or continuous. Amount of oil in a car at any given time. Car may hold 6 quarts total. Maybe down some, but if you look at how much amount of oil in a car at any given time, it's not maybe exactly 4 quarts. Maybe it's 4.2 quarts or 4.23. You can keep measuring it if you had a finer way of measuring it. You can keep putting more decimal places on there. That's continuous, has decimals. Now, number of deer in a forest. Well, you can't have 2.5 deer in a forest. You can't have half a deer. It'd be dead if you cut it in half. So this would be discrete. You'd have 1 deer, 2 deer, or 3 deer. Age of a student. Now this is kind of the little bit confusing part. In class, I kind of poke fun. I'll ask somebody to give me their age, and they may say they're 22. And I say you're lying to me. And they look at me kind of funny sometimes. But I say, unless you're actually born on this day, this hour, this second, this millisecond, keep going down, that's not really your age. Your age is actually maybe 20.573. So it does have decimals. But if you think about how we treat age, we always treat age, at least when you're an adult, as discrete. You ask somebody their age, say 20, 21, 22. So that's why, when you run across the age of a student, it's actually continuous, but we treat it as discrete. If you were doing a study, you'd want to make sure that you specify specifically what type it is. Temperature of the water in a swimming pool. Now, we tend to think of 33 degrees, 34 degrees, 35 degrees, but if you think about it, there's actually some in between. If you had a fine enough measure, it could be 33.5, 33.2. So this has decimals, so this is continuous. Now we have individuals, person or object that is a member of the population being studied. We have the variables, the characteristics of the individuals within the population, and then data describes characteristics. Now, 15th example says identify the. Got spelled variables wrong up there. Oh, that's horrible. I hate misspellings. Identify the individuals, variables, and data corresponding to the variables. I spelled it right there. Determine whether each variable is qualitative, continuous, or discrete. Well, The individuals, let me go back. Individuals is a person or object that is a member of the population being studied. Individuals would be Sam, Sally, and Bill. Now our variables would be hair color, age, and weight. That's what we're studying. And the data would be these values in here: black 33, 250, red 21, 120, and so forth. You determine whether each variable is qualitative, continuous, or discrete. If I look at hair color, well, that's qualitative. It's not a numerical measure. Age, that's quantitative. It's a number, and again, we treat age typically with no decimals, so that we'll say this is discrete. Now weight, a lot of people will put decimals in there, like I'm 130.5 pounds. So this is continuous. Now we've got different levels of measurements of a variable. Nominal level is like hair color. Ordinal level, nominal is a name, label, or category like hair color. Ordinal is properties of nominal, but you can range by rank or order, like car size. Interval level, properties of ordinal and differences in the value of the variable have meaning. Year of birth, for example. Now 0 doesn't have any meaning here. Year of birth, 1965, 1983 when you're born. If you told people you're born 0, it's just like, what? Addition, subtraction, okay. Ratio. Same properties of interval and a ratio of the variable. Ratios of the values of the variable have meaning. Zeroness measurement means absence of the quantity. Multiplication and division could be performed at this level. Value of a car. It could be worth 0. It's not worth anything. So 0 makes sense here. Okay, color of a car. It says determine the level of measurement of each variable. Well, let me go back. That's nominal. That's category. So color of a car is nominal. Class in high school. Freshman, sophomore, junior, senior. Let me go back again. It's not a category, but it can be arranged. Freshman comes first, and sophomore, then junior, then senior. So it's ordinal. Year of graduation. Well, we've already talked about this. Because previous one was a year, I think, also. Okay. Interval. That's where the difference in the value of variables have meaning. Year of birth. So that's the interval. And I won't flip back for this next one. Weight of students. So that might say 0 doesn't make any sense here. So a student can't necessarily weigh 0. I suppose if you look at them at what stage they are, maybe a cell would weigh 0 pounds. But anyway, that's ratio. And that's the end of that section. So let me stop the different recorders here. And oops.